Assalamualaikum warahmatullahi wabarakatuh. My name is SAFIRAS binti ISMAIL, and today I will be presenting on Green's theorem subtopic. By using the Green's theorem, we will be able to evaluate the line integral of a smooth vector field around a simple closed curve. Let R be a simple connected plane region whose boundary is a simple closed piecewise smooth curve C oriented counterclockwise. If fxy and gxy have continuous first partial derivatives on some open set containing R, then the equation will be as given here. The integral of closed curve C fxy dx plus gxy dy is equal to double integral region R del g over del x minus del f over del y dA. And do remember that dA can be either dx dy or dy dx. This method allows us to evaluate either a line integral around a closed path C or a double integral over the area enclosed. This is the simple closed curve C and the region R. For example 1, evaluate the integral of closed curve x squared y plus 1 dx minus x squared y dy over the triangle formed by the lines y equal to 0, x equal to 1 and y equal to 2x. For the sketching, this is the line y equal to 2x, x equal to 1 and y equal to 0. For the sketching, we can use the online graphing calculator, and this one is from GeoGebra. So input the equation is y equal to 2x, y equal to 0 and x equal to 1, and we get this graph. For the solution, by using the Green's theorem, since fxy is equal to x squared y plus 1 and gxy equal to x squared, the integrals become double integral R del x squared minus del y x squared y plus 1 dA. Since f is differentiate to the respect of y and g is differentiate to the respect of x. For the limit of y is from 0 to 2x, while the limit of x is from 0 to 1. Then differentiate to the respect of y and we get the equation 2x minus x squared y. Then evaluate the function by substituting the value of 2x and 0. Then we will get the equation for x squared minus 2x cubed dx. Then differentiate with the respect of x, we will get 4 over 3x cubed minus x power 4 over 2. Substitute the value of 1 and 0 into the equation and we will get 5 over 6 as the final answer.
Hi, my name is FAHMI, and I will continue the presentation of our group by explaining how to solve a question using Green's theorem. The question is, use Green's theorem to evaluate the line integral 1 plus xy squared dx minus x squared y dy, where C consists of the arc of the parabola y equal to x squared from point -1, 1 to point 1, 1. So first step is we need to draw the graph. The equation is y equal to x squared. So x squared is not a straight line, it's a curve like this. X is positive, so it's a smile. So the point -1, 1 is here, -1, 1, and point 1, 1 is here. So we can obtain the limit. So the region is here, and we can obtain the limit of x and the limit of y. Now I will teach you how to use a graph generator, which is decimals. First, we insert the equation y equal to x square, and the limit is -1 to 1. The limit of x is -1 to 1, and the limit of y is from 0 to 1. So we get the region here. Now we have to solve the equation using the Green's theorem. 1 plus xy square is equation if the equation of f, and -x square y is equation of g. So how we going to solve using Green's theorem is we differentiate the equation of g with respect to x, and we differentiate the equation of f with respect to y, and we get this answer. Then the limit of y is from x square to 1, and the limit of x is from -1 to 1. Then we solve this problem by integrate the equation. So we integrate -4 xy is -2 xy square. Then we substitute the x square 1, -2 x. So we get -2 x power of 5 plus 2x. Then we integrate this, we get this answer. And we substitute -1 to 1, we get this. And so the final answer is 2. Thank you.
I'm NURUL AFIFAH, and I'm going to explain a question in divergence theorem in cylindrical coordinate. The question says that use the divergence theorem to evaluate f and ds where vector field f is equal to 2x zi plus 1 minus 4xy square j plus 2z minus z square k, and S is the surface of the solid E bounded by z equal to 6 minus 2x square minus 2y square, and the plane z equal to 0. First thing first, we sketch the graph using the information given, and I get this graph by using GeoGebra 3D calculator, and this is the website GeoGebra, and I set 3D calculator, and at first I insert z equal to 0 and set the color as blue. As you can see, this is the blue. Is z equal to 0. Next is z equal to 6 minus 2x square minus 2y square. Alright. Okay, so this is how I get the graph is a paraboloid. Next is the solution, which is as stated in the notes given. The divergence theorem use f and ds is equal to the integral of solid E divergence vector field f dv vector field as given in the question. So how do I get the divergence? Is by is the dot product between vector field f and the partial derivative of each x, y, and z. Okay, and I got 2z minus 8xy plus 2 minus 2z, and 2z minus 2z is equal to 0. So the answer is 2 minus 8xy. Next, we have to determine the limits, and as we know, for theta we have 0 to 2 pi because it's a 0. Sorry, it's a circle. And next, r is here. As for z, I also use the function given, which is the paraboloid, and then I change it into cylindrical coordinates. Next, we continue with the solution here. Alright, so this is the triple integral of the solid E. is the divergence of f that we already got here, and then we put the limits accordingly and change it into cylindrical coordinates. So for x is r cos theta, for y is r sin theta, r dz dr d theta. Okay, next I simplify it, and I got 2 minus 8 r cubed cos theta sin theta dz dr d theta. Okay, so this is the continuation. As usual, we integrate with respect to z, and we get 2r minus 8r cubed cos theta sin theta z, and then we substitute 0 to 6 minus 2r square into z, and this is how it is, and we expand it, and I got this. Okay, next I integrate it with respect to r, and I got 6r square minus r to the power of 4 minus 12r to the power of 4 minus 8 over 3 r to the power of 6 cos theta sin theta, and then we substitute the limits 0 to 3 into r, and we got this. As for this, we cannot directly integrate it. We have to simplify it by using u substitution. And for this part, I actually used a website which is a symbol lab. It helps. You just insert this equation, and it will simplify it for you using u substitution or whatever that suits. But for this equation, it was solved using u substitution, and then we can integrate it as usual with respect to theta, and then we got 9 theta minus 9 cos 2 theta, and then we substitute 0 and 2 pi into theta, and we get 18 pi for the final answer. And that's all. Thank you.